Ever wished your car could just drive itself? Especially during rush hour? Well, imagine that, but for like massive cargo ships. You know, crossing oceans, that's the dream, right? Ships just sailing themselves.
No captain required.
Exactly! Sounds like science fiction.
It kind of does.
But the technology is almost there, isn't it?
Almost being the key word.
Right. You sent us this fascinating research paper, ENC, for autonomous navigation, and it really digs into why we're not quite there yet.
It does, and it highlights some surprising roadblocks, I think, along the way.
Yeah, totally. And the paper is by Andrei Sabodash. He's the CEO of Geophone SW, which they make navigation software specifically for ships.
So he knows what he's talking about.
Yeah, he's definitely an authority. And he basically says that even with, our super advanced computers and these incredibly detailed digital maps, which are called ENCs, by the way.
Right, ENCs.
We are still a ways away from ships that can really, truly sail themselves.
The technology is there, but it's more nuanced than that.
So are we saying it's almost like having too much of a good thing?
It's a great way to put it. Because too much information can actually be a bad thing.
Okay.
And that's exactly the problem that ship captains are facing today. It's what I like to call digital overload.
So even with these awesome digital maps, human judgment is still key. Why is that?
Well, you see, that's the paradox that Sabodash is getting at, right?
Mm-hmm.
We've got these ENCs, these electronic charts, but they're only as good as the data and how well we understand it. Humans and computers. Because believe it or not, getting a computer to make sense of all this data and then use it to actually safely navigate a ship is, well, it's way more complicated than it sounds.
So how should automatic navigation work? Like, in a perfect world? Let's break that down. Okay, so picture this. We've got these incredibly detailed digital maps, but just having the map isn't enough, is it?
It's like having, Google Maps, but no clue how to use the navigation.
Exactly. So how do you actually teach a computer to navigate a ship, like on the open ocean?
Well, that's the million-dollar question, right? And Sabodash's team actually developed this really, this algorithm that's designed to do just that. It's based on this idea of no-go zones, which I gotta say, pretty brilliant concept.
No-go zones? What is that?
Okay, so imagine your GPS, but like way smarter, right? Like it knows exactly how much clearance your car has.
Yeah.
Not just for height, like the low bridges.
Right.
But for width too.
Uh-huh.
So it wouldn't even let you start driving down a road if it knew your car couldn't fit, right?
Oh, I see.
These no-go zones are kind of the same idea, but for ships.
Okay, so instead of roads, we're dealing with the ocean floor.
Exactly. And that's where the bathymetric data on the ENCs comes in.
Bathymetric data.
Yeah, it's just a fancy word for depth measurements, of the seabed.
Okay.
The algorithm takes this data, combines it with the ship's draft, which is basically how deep the ship sits in the water, and then it creates these no-go zones, and it does it all in real time.
So it's like if the water's too shallow, the algorithm just throws up a big, danger Will Robinson sign.
Basically. And the ship has to find a different route.
That's wild. And it can actually do that, account for the ship's specific size and everything.
Yeah, that's the idea. And get this, Sabodash's team, they actually made this interactive website, and you can actually see this in action. Like you can change the draft of the ship and watch how the no-go zones change on the digital map. It's incredible.
No way. We are absolutely putting a link to that in the show notes because our listeners have got to see this. I mean, it sounds amazing. Okay, so in theory, this solves everything, right? Safer routes, more efficient, maybe even prevents accidents caused by human error. This all sounds a little too good to be true. What am I missing?
Well, like with most things, the reality is always a little bit more complicated.
Okay, here comes the idea.
Yeah.
What's the catch?
So when Sabodash's team, they took their algorithm out for a spin in the real world, and they used live data from ships, to see how it would actually perform. There were some, shall we say, surprises.
Surprises, as in the ships just ignored the no-go zones?
In some cases, yeah.
Yeah.
They found instances of ships sailing right through areas that the algorithm had flagged as do not enter.
Oh no.
Yeah, it's that's where things get interesting.
Hold on, so ships are just ignoring these warnings and sailing straight into danger? What are we talking, reckless captains throwing caution to the wind here?
Well, it's easy to think that, right?
Yeah.
But what Sabodash found is it's not that simple.
Okay.
Blaming the captains, it's a little too easy. He dug a little deeper and found some pretty big problems with the ENCs themselves.
The digital maps.
Yeah.
Okay, so it's not the captains, it's the maps. What are we talking about? What kind of problems?
So two major things, actually.
Yeah.
The first is what we call data discrepancy.
So you had a discrepancy.
Yeah. So think of it this way. You're driving down the highway, right? and your GPS says the speed limit is 55.
Okay.
But then you see a sign that says 45.
Right. Which one is it?
Exactly. Which one is right?
Yeah.
That's essentially what's happening with these ENCs sometimes. The depth information, it contradicts other sources.
Wow. Okay. So it's not just about having data, it's about having the right data.
Exactly.
So what's the second issue then?
Okay. So imagine that same highway.
Okay.
But this time your GPS shows like a big blank space where a whole section of road should be.
Oh.
Right? No speed limit, no exits, no information. That's the second issue. Missing data.
Oh my gosh.
Yeah, there are huge areas, especially in coastal waters.
Yeah, makes sense.
Where the depth information is incomplete or just totally missing.
And I'm guessing that makes it basically impossible for the algorithm to work?
Exactly. It's like trying to solve a puzzle with like half the pieces missing. You can't do it. Without accurate, complete depth info, these no-go zones, they're, well...
useless.
Yeah, pretty much.
Okay, so data discrepancy, missing data, sounds like we're heading for disaster.
That's a problem.
Yeah, but what's the root cause here? Why are these digital maps so unreliable?
Well, Sabotage argues it's because these ENCs, they're still designed mostly for humans.
Okay.
To captains to look at.
Right.
We prioritize visual clarity over the raw data a computer needs.
Interesting.
So it's a bit of a mismatch.
So how do we fix it? Do we just need more data, more measurements, more detail, more everything?
It's not just about more data, it's about smarter data.
What do you mean?
We need ENCs that have enough info to make 3D models of the seabed.
Okay.
Even if that's hidden, like not something a human would see on the chart.
Oh, interesting. So like a secret layer of data just for the computers?
Exactly. A digital blueprint so they can get it right.
That's so cool. So what would that look like? How do we actually do that?
Well, Sabotage has a few ideas. One is to just, include way more depth measurements from the start.
Okay.
So we're building these ENCs with both humans and computers in mind.
Makes sense.
Another idea is to have a standard way to flag areas where, the data is iffy.
Right. So we're not assuming everything's safe unless it's marked. We're marking the dangerous parts even if we don't have all the info.
Exactly. Kind of a warning sign for autonomous ships.
Makes sense.
And finally, we need stricter data checks.
Oh, yeah, like quality control.
Exactly. Catch those errors before they cause problems.
So more data, smarter data, and cleaner data, that's the ticket.
That's the recipe, yeah.
Sounds like a tall order.
It's a challenge, for sure.
It really highlights how complex this whole thing is, right? It's not just about building a smart computer, it's about rethinking how we approach navigation data as a whole. Makes you wonder, what other technological advancements are we missing out on because we haven't quite cracked the data code yet? Something to think about, right? As we continue our own deep dive into the future of, well, everything. Thanks for listening.